opportunities. So, my name is Eva Koch, I work for TST Solution. I will very shortly present you the TELLME project, which I coordinate. I will describe which are the objectives, very shortly which are the industrial pilots in industrial sectors where we plan to validate the results. Then, in a nutshell, I will present the scientific approach that we are adopting and also the IT infrastructure and architecture that will develop some services to support this approach. So as you can grasp from the acronym, TELLME is a technology enhanced learning project, in particular funded under the action for deployment of learning solutions directly at the workplace. We started in November last year and we will continue for 3 years, and TST is the coordinator. So even if this is not a Factory of the Future project, nevertheless it's very focused on the manufacturing sector, and that's why I think it's really relevant to share some insight with you. As for the consortium, we have a scientific side, a scientific soul, with some universities from Europe and also some private organizations which are dealing on the scientific side of the technology team. We have 6 technological partners in charge of developing the architecture and tools to support this approach. And then we have 3 end users, who are representing a business ecosystem of small and medium enterprises. So there are some questions behind TELLME and in general the technology enhanced learning projects. One is if really there is a separation between learning and production, and if it is really necessary to remove resources from the real production when we need to teach them, or if this is a sort of artificial separation that we can somehow cope with, or thanks to new technologies and new devices. So our objective is to provide these training solutions to blue-collar workers, mainly coming from SME, which have some difficulties to follow the pace of other larger organizations, and specifically SMEs from the manufacturing sector. And this training will be provided directly at the workplace. So all this, the overall solution will consist of a meta methodology and some services plugged into a platform, which will allow to combine different existing methodologies like precision teaching, for example, like lifelong learning, and to merge them with models like the Living Lab in order to stimulate also the creativity and the co-creation by the workers. As for the pilots, we have identified 3 different pilots in 3 different sectors in order to demonstrate the adaptability of the solution. The first one is in Augusta Western, so in the aerospace sector. In particular, we will address support of the technicians who are in charge of maintaining the helicopters, and this is a very complex activity because they have very dedicated tasks to execute, and they need to be continuously updated because these helicopters are very complex and change frequently. The other sector is completely different, and we are addressing workers in charge of assembling furniture in quite an unusual workplace, which are the ships, so they have to cope also with some problems related to the environment, the physical environment in which they have to operate, and they have to be supported in understanding how to make this assembling task and also how to perform some finishing activities on this task. And the third sector is textile, in particular supporting workers who have to recognize and repair sometimes defects on different kinds of the fabrics. So as for the scientific approach, we have identified 4 learning areas or learning challenges, and the first one is the provision of deep professional competence. So the objective is to support these workers in developing high-level competencies, very specific in specific professional domains. This objective is supported by other challenges, and in particular, as for the innovation, we want to train workers in order to help them developing the capacity of finding new ideas or new ways of performing tasks and to make new activities in a creative way. As for the lifelong learning perspective, these people have to be able to learn continuously, and in particular to be able to learn each time they have to face a new situation and to adapt their activities. And for what concerns the network learning perspective, we will support these workers to develop some social skills so that they are keen to share their competencies, their knowledge, and to cooperate in team group, and also be able to cope with some conflicts that naturally arise when they have to work in a team. What we are developing is a meta-methodology which is called the MMO, the Mixed Match Optimizer, which is based particularly in three different steps. The first one is the mix step. Here, stakeholders, which are the workers, but also the trainers, and in a broader sense, also the companies, are encouraged to test and to find out new ways of combining methods, contents, and also delivery channels in a new way in order to maximize their possibility of success. So they are going to test and to try and to combine these approaches. And they have the control, so they can perform their own choices. Of course, these choices might not be completely correct. So in the second step, the methodology will support checking if this mix is compatible and is complete with regard to some target objectives they have identified. So we measure the adequacy of this mix with regard to the learning goals. In the third step, methodology will support the identification of some improvements in this mix, so that this mix can be changed as the methods or the content, also for what concerns the delivery devices. So just to give an example, if you think about explicit learning goals, so some learning needs that are already well known in the company, for example, one stakeholder can decide, one worker can decide to mix together structured teaching solutions with method discussion. So in the first case, the system will provide a combination of different learning contents like audio, like diagrams, like videos, like simulations tools, and some tests at the end of the course. And these are combined with some mentoring support provided through audio and from using web-based chat, for example. During the match step, it can be identified some gaps. So the system will suggest to the worker to try different choices. For example, the first combination in step 1 can be changed in order to better match the objectives. So as for what concerns the MMO in the factory of the future, this methodology has the objective of supporting companies in finding new solutions for training which are more economic and more effective, and that are able to face some challenges arising from the manufacturing sector. So, for example, we have selected some challenges mentioned in the foundation project. So, for example, supporting the cooperation within the supply chain of partners. In this case, TELLME will leverage mostly on the social dimension of the TELLME solution, and will support and will encourage the adoption of the living lab model in order to share this and cooperate within and across the supply chain. In order to achieve high quality of the operation, and also to be able to produce under pressure and under some other environmental constraints, TELLME has studied how to use some methodologies like precision teaching to teach the workers in order to retain some behavior and be able to react in the correct way, even if they have to work under pressure, under in time constraint and in a particular environmental situation. And as for some other issues related to the need of tracking and managing information and also to work in a safe way, again, this methodology will support the workers in order to learn how to work and retain this behavior in order to work always in a safe way, and also to think about the environment and to work in order to be sustainable in these activities. Okay, as for the, as I mentioned, this scientific approach and this methodology is supported by architecture and some services. In TELLME, we see the physical workplace as a combination of three different dimensions, so it can be thought under three different points of view. In the smart dimension, this is a system which monitors the environment in which the work is operating and is able to collect some data from sensors and to identify some learning needs and to suggest the contents and learning solutions directly to the worker. So in this case, it's a system which analyzes the needs of the worker. In the human dimension, on the contrary, is the human person, is the worker, which has some training needs and asks the system in order to be supported. And the system will provide the correct contents, taking also into account which is the context in which the work is working. And the social dimension, the system will support the worker and it will encourage in spreading the experience and know-how across a community, both for sharing but also for asking additional support. Now, for what concerns the architecture, this is a very simplified version of our architecture. The idea is that we are addressing people in their workplace where they have some mediators, some tools in order to operate on a certain object, and the system will support them through different devices, which might be tablets, mobile phones, or also augmented reality devices like Google's. From this workplace, there are some learning needs that are addressed to the system, either through this interface, so there are some learning needs that the user addresses to the system using these devices, or it's, as I mentioned, the analysis of some signals which detect a learning need from the worker. Then we have reasoner, which implements the rules expressed in the meta methodology and retrieves some contents from a set of repositories. These contents are then redirected to the workplace or to the work site where the workers are working, and also sometimes with the mediation of specific learning content delivery engine which implements specific methodologies. And finally, from this workplace, there are some feedbacks which are then put into the repositories and used to analyze the behavior and also the needs of the workers. These are just some pictures to describe which are the devices that we plan to provide to the workers in order to be supported by the TELLME system. So, for example, when they are operating within the helicopters, they need some tablets probably, or some augmented reality devices. In the furniture domain, our end users are keen to use some augmented reality tools to see which is the final result of some assembly task. Okay, so some conclusions, just to sum up. There are some specific training needs which are specific of a single worker that requires a training solution that are created for the single worker. So then we will support this identification of this solution and also the deployment of this solution using methodological and technical solutions. We are validating in different sectors, but nevertheless we are working in order to identify which are the general needs coming from the manufacturing sector, from other sectors that we are not addressing specifically in our pilots, in order to prove the general flexibility of the solution and also the adaptability in different contexts. Okay.
Thank you. example of a project developing which develops technologies for enhanced living. Now we'll have an example of a project which develops living for factories of the future.
Thank you, Dimitris. I was asked yesterday to give or to provide some input from the Vistra project to the learning issue, and I'm very happy to do this. But I have to do this very quick because I have to catch my train in half an hour. And thank you for advancing my presentation. So yesterday we have learned about the Vistra project from the data perspective. In the project we try to develop low-cost, large-scale virtual training of complex manual assembly tasks and processes, mainly for automotive industry. And we have some really key requirements from our end users. They want to have the system highly intuitive and interactive so that every stakeholder from young to old can use it with different technological acceptance levels. They want to have this training tool as intuitive and motivating and engaging as possible. So we decided for a game-based approach. And they want to use that on a flexible level, on a large scale. They want to have a mobile and extensible training solution. So here we have no chance to use arcade, for example. We are limited to consumer interaction devices, which are available at low cost. And finally, the solution has to be well integrated in the organizational structures of the enterprise. I could present you our prototype yesterday, and this is what we are doing from the technical development in the project. I missed to mention yesterday that we plan to bring Vistra into a product by the end of the project, and at the moment it looks very well. We are well on track in doing that. But we have also another perspective in the Vistra project. We want to look ahead and define a roadmap on computer-based training. And therefore we started the internal roadmap building process where we first state the different influencing factors. Then we try to deduct the needs for the learners in the future factory. And we want to see which emerging technologies can be used to develop new kinds of training solutions. So the document which we developed, it's a draft document, but it's available on the website. You can look that up if you want. So here we have stated some basic requirements regarding the future qualification needs in the factory of the future. I will skip that. And the road mapping process was broken down in two topics. The first topic is about the content sources, where computer-based training depends very much on the efficiency of how to create it and how to set it up. We do not want to spend too much time in the data preparation. Then the delivery mechanisms are also very important. This is the second topic which we investigated. And the third topic is about the learning process. And I will start with the learning process. So classical vocational training is mainly based on a series from behaviorism and from cognitivism. And we would like to go for new learning series like situational learning and network learning. So we think that in future training takes place embedded in the daily work, and it takes place continuously. We think that learners have to interact with their learning environment instead of being passive. And we want to provide training at the ad hoc basis, at the right place of action, at the right time, when it's needed. And this can be, this should be supported by computer technology, which is always available. And this computer technology should complement, maybe not replace, but complement the roles of teachers, mentors, and experts. So one thing which we state is that the learning curve and the need for assistance and training is very interesting to be investigated more. I think we move forward to a stage where the difference between assistance and learning becomes less distinctive. When an operator is completely new and unexperienced, he needs high or very well assistance. So he needs step-by-step instructions. And then when he begins to explore his environment and he starts to reflect on what he has learned, we can reduce the amount of information. This is what we call fading. And in the end, when he becomes the expert, he doesn't need any support at all, or only upon request. So we must develop adaptive learning systems. Moreover, the second topic about content source, I think we have two very nice sources in our enterprises which are not yet integrated in developing training system. One of this source is the digital factory, the PLM. We talked about it yesterday. The other source are the workers itself. So they have a lot of knowledge, but this knowledge is mainly implicit. So we have to find ways to make the knowledge of the workers explicit, to make that available in models and to capture that knowledge. And once we have modeled our training or our content in the factory in a modular and semantically expressive way, then we can combine different kinds of information and create new applications. So what we do in Vistra is we use the product structure information in the station layout to set up virtual training. We could use station layout and technical documentations to provide the right information at the right place. Just take your smartphone, scan the barcode, and you get your PDF as a very, very simple example. Yeah, and then finally, the delivery mechanisms. We do very much research in advanced user interfaces, advanced visualization, and serious gaming, and we think we have a great opportunity to use that new technology. And yeah, we are maybe not yet aware of what we can do with that, but we should further investigate on also this data provision technologies. So we have then, based on the information which we captured, created some scenarios describing how this future training could look like. This is actually the Vistra use case. We have also other scenarios like the assistants in the factory using head-mounted displays and tablet PCs, context-sensitive information provision, and so on. I don't want to go into detail. If you have more questions, if you want more information, just come to me. That's all from my side. Thank you.